Hi folks, this is tutorial number 7 in the playlist, which is dynamics scenario creation in 3D experience. And it's a very simple problem. Actually, it's a block that is subjected to a time-dependent force. For example, at the centroid of it, really doesn't matter. And this is going to accelerate. And I did a problem like that in tutorials 4 and 5, except that the force was constant. I want to show you what happens if the force is not constant. It's a function of time, and you want to input that in the within the platform. So let's say that uh, the 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 block or the box is made out of steel, point 1 meter in each dimension. And there's no gravity. I just turn off gravity. It's just accelerating on the force applied. Maybe it's in outer space. And the mass of the block, if we use steel properties, is almost this about 8 kilogram. And I'm going to do a simulation over 1 second interval because I want to show you what happens over 1 second. Now, the force that I want to apply is actually 5 plus 10t. Notice that when t is 0, of course, there is an initial force of 5 based on this formula. And uh, yeah, so except that just keep in mind that really what these numbers are, the 5 is 5 Newton, and the 10 here is 10 Newton over 1 second. So that if you multiply t by this, seconds cancel out, so you get Newton plus Newton. So you have to be careful when you input these things in the software using the formula. Now, uh, the bad news is that you can do it with formula, but if it's more complicated, if the variation of f of t is more complicated so that it's time dependent, etc., etc., if time is between 0 and 5, this is it, or 0 and 2 seconds is this is the expression, if it's between 2 seconds and 7 seconds, it's a, so in principle, this should be doable. And in fact, you can go ahead and do that, but it won't run. So the bad news is that when you try to use rule instead of formula, doesn't work. I'll show you. Now, uh, based on, in order to assess the quality of results that we're getting, notice that if you have the force divided by mass, you're going to get the acceleration. Integrate the acceleration, you're going to get velocity, and integrate the velocity, you're going to get position. Now, these are the initial velocity, initial position. In these simulations, we're going to assume these are 0. Initial velocity is 0. That position doesn't matter that much, but the problem is that you cannot incorporate, or I was unable to incorporate initial velocity anywhere in the code. Like it doesn't have a provision for that, okay? Now, it is possible to put initial velocity in the form of an impulse, impulsive force. The problem is that to do an impulsive force, you need to use a rule, and I told you a rule does not work. So anyway, that's the fact. Now, I'll come to these, if necessary, I'll come to these in a minute. I will come to these slides in a minute, but here's a force law excitation. Now, in tutorials 4 and 5, I believe I use this, except that I put a constant value here. If you have non-constant value, you put the cursor there, right-click, and it allows you to opens up the formula dialog box, and you can put the right-hand side in it. Okay? And notice that this is just a single line, equal to a single line. You cannot put if statements there, etc. That has to be done with the rule that I couldn't get it to work. I don't think it's working. So we're going to check in our result against the acceleration based on the data that I gave you. The acceleration, of course, initially there's a constant acceleration there because there's a constant force, 5, remember, 5 initial value of the force. And then the velocity is going to be parabolic and the position is going to be cubic. So whatever we generate, you should be able to match these graphs. Okay, so let's go ahead and do that. Let me start with an assembly. Let me insert a 3D part. That's going to be the box. That's all we need. Let me call this thing the box. Properties. Box. And box. Very good. Let's go make it. Double click on this. You're in part design. So on that vertical plane, I will sketch a square 0.1 by 0.1 meters. Exit, add it. Actually, I want it in both direction and 0.05 so that we get actually a box. There we are. And I want to create a point at the center of this, because if I put that force on a corner, this would not only move, but it would also tumble. I don't want that thing to happen, so I'm going to create a point right at the centroid of the center of gravity and apply the force there. So while we are at it, here is a point, center of gravity of the pad, and then say, okay, so it's right at the center of gravity of this. Let me hide these planes, I don't want them. It's easier for you to see the point. Good. Now we're done here. So we go all the way to the top. We are in assembly design now. Now notice that I'm not going to fix this, because if I fix it, this is never going to move. Okay, so there is no fixed part. Okay, so now we're going to go to mechanical system design, right there, mechanical system design. That's what we have been doing in these tutorials. And I'm not going to fix anything. Okay. And let me see now. Here we have mechanism representation. And let's see what's in it. Pretty much nothing. Okay, that's fine. Now, we have to apply material properties to this. So the way to do it is you go to the very last icon on the right, widget, weight definition. You click on it. It says 100% is missing. So you select either you can select the box or you can select the assembly. It really doesn't matter. I'll select the box. And it says click the hyperlink here to declare the weight. You can put whatever you want there, but you want properties of steel. So I'm going to check this box. See that? See this box over there on the top left corner? And it puts the properties of steel. And then based on those dimensions, it's going to be 7.77 kilogram. Okay, good. And we're done there. And we're done there. That's pretty much it. Now we're going to go to mechanical systems experience. Create a mechanism. No, already we have a mechanism. It's right there. It doesn't have any joint, but that's okay. All right. There is no gravity. If it was, I would activate it there, or just leave it the way it is. And now what we want is force law excitation. You click on this. Okay. Support. The support is this box. See that? The box. The point of application, you put the cursor there. You can select any point that you want, but I put it here because I don't want this thing to tumble. Okay. The direction, well, that direction of this, for example, edge. Okay, if you want it to go in the other direction, let me flip it. Now this is the default magnitude of 1, but I don't want a constant value. So you put the cursor there, right click, see that, edit formula, see that, right there. So what I'm showing you is basically, what is that, this, okay. So let's go back there, right click, edit formula. This opens up, so the force equal to 5 Newton plus parentheses 10 Newton over 1 second times time. You select time here, left double click on this to put it there. And if there are any syntax error, it's going to pop up. Now, so what I did here is actually inputted this formula for you. And then we say, okay, good. Notice that we have an f of x here. See that? We have an f of x here. And this is the initial value, 5. And then we say, okay. We now go and, why don't I create a probe there too? So here's a probe at that same location, and then close it. And now dynamic scenario, force excitation, you send it there. Probe, you use it. For parameters, it really doesn't matter. I will show you both of them. It's going to be pretty much the same thing, okay? So I can use because this doesn't involve any contact, doesn't involve any coefficient of restitution, etc. The only things that I'm going to do it over 1 second. Okay. Say okay. And run it. What's going to happen is that this is going to move to the right for 1 second, and it's going to stop. Okay, now, all right, let's check some of the results. Okay, so click on the scenario results, deselect all, select the, for example, the position, vertex in the x direction, and you're going to get this. The only thing is that when you look at these things, they don't quite, the numbers are the same, but they don't quite agree with the concavity of these. That's because I'm pushing this thing in the negative. You see that? In the negative x direction. So if you want to get exactly those results, I'm going to be pushing this thing to the left. So let me get out of this. We go back to scenario or excitation. Flip the arrow, reverse the arrow. Okay, now let's go ahead and run it. And now look at the results. And you're going to get exactly those things those graphs that I showed you. So deselect all. If you look at the, for example, the Z X vertex plot, you're going to get this. If you look at the acceleration, you're going to get constant. X acceleration is right there. Notice that it starts at 0.5, then it goes up. And if you look at, for example, velocity, it's going to be parabolic linear velocity x, right there. And this is totally independent of the solver. For example, if I close that and I go to that scenario and I change this thing from DA, this was symplectic DASSL. Okay, so play it. It's going to be exactly the same result. So go to results. If you look at, for example, position or acceleration, let's look at the acceleration. Same thing. Now, I told you that if, for example, our excitation, force excitation, is more complicated than just this. By the way, look at what I did. I double click on force excitation, I click on this f of x, it'll give me my formula. If your situation is more complicated, for example, if time is less than 0.5, here is the force. If time is between 0.5 and 1, here is the force, etc. You can use a rule, and not we have to write a few lines of code. But I'm going to show you there is some issue with that when it comes to using. Actually, I'm not even going to bother. I'm not going to even bother writing a complicated rule. Here's what I'm going to do. Cancel that. Cancel that. You go to Tools. This is what we have done before. You go to Tools, Run Scenario. You go to Simple Rule, rule number 1. And I'm going to say, just to convince you that there is a problem in this implementation is that I say force. I want to change the value of the force. I'm not going to even bother saying that if time is less than this, here is the force, else here's the force. I'm just going to say, okay, you know what? Just change the force to 1000 Newton for me. And then say, okay. This is going to come back and say, it looks familiar to you because we have seen this kind of warning before. It says, you are going to be replacing a formula with this. Are you sure? See that? Do you want this new relation to become the active valuating relation for the formula? The answer is yes. Type yes. In this relation, you will add this relation as an active and will deactivate the other one. Say yes. Good. Look at what happened here. The formula is deactivated. I'm just going to make a constant force. If you can check that, left double click, constant force, no problem. Okay, good. Now let's go run it. Let's go run it. See what happens. It's not going to even move. There's something wrong with linking of the rules as it was working before when it comes to forces. Something wrong, or I don't know how to do it. I think there's something wrong. All right, folks, good luck.